Hello everybody, I am Rajendra Kulkarni. Welcome to my channel Programming in C with RSK. In this video, we will be discussing about pointer arithmetic and also about pointer to a pointer. So let's begin with our slideshow. Pointer arithmetic will be explained to you using a small program. One variable x of kind float declared and assigned with a value of 4.5, and the other variable declared is a float star fptr, where fptr is a pointer to a float variable. The value of address of float variable x address is assigned to fptr. fptr is equal to ampersand x. In this statement, printf contents of fptr is equal to %u fptr. What we are getting is address of x assigned to fptr. Now what we are doing here is fptr plus 1. So what in effect we are doing? The contents of fptr are being incremented by 1. And then again we are trying to get how much is what is the content of fptr after this addition of 1. Now in this statement we are again decrementing the contents of fptr and again finding out with this printf statement what are the contents after decrementation of fptr. Contents of fptr, this when we assign the address of x variable to fptr, x variable is stored in 65522. So fptr contains the address of x, which is 65522. On incrementing the fptr by 1, the contents of fptr change to 65526. So when we add 1 to a pointer of type float, its contents are incremented by 4. So what it actually does is incrementation of a 1 will cause the pointer to point to the next location for a float kind of variable. Similarly, when we decrement fptr, the value or the content in pointer fptr are again 65522. So these are decremented by 4 locations. So what is pointer arithmetic tells us? When a pointer is incremented or decremented or any arithmetic operation is done on it, the only 2 arithmetic operations we can do on a pointer, either addition or a subtraction. Can't do others like multiplication or division. So addition or subtraction to a pointer causes address held by it to increment, decrement depending upon the data type to which the pointer is declared. So when a pointer is a float pointer, addition or subtraction of 1 will cause the contents of the float pointer to increment by 4 bytes. The address will be incremented to next location where a float value is stored. In case of int variable, when it is incremented by when a int pointer is incremented by 1, it starts holding an address of the next int which is 2 bytes away. So it increments by 2 bytes. In case of char, it will be incremented by 1 byte. As there is a pointer to a variable, in this slide we will see what is a pointer to a pointer. Look at the declaration float a is equal to 10, double star b, star b and star c. These are the three variables declared. One is a float variable a, another is a pointer variable b, which will be holding, to which we will be assigning the address of another pointer, and c is a pointer variable. C is equal to ampersand a, address of a will be assigned to c, b is equal to ampersand c. So what we are doing in this statement is address of c is being assigned to b. C being a pointer itself, the notation for a variable to which we are going to assign the address of another pointer variable must appear as star star b, or 2 stars should be used for declaring a variable to be a pointer variable to which another pointer address will be assigned. Now this printf statements gives us various addresses and contents. The address of a, b and c are being given by these three printf statements: address of a, address of b. B is again a pointer variable, so it must reside in the memory at a particular address. That address is being given by this statement: address of b is equal to %u and b, ampersand b. Similarly, address of c we get through this printf statement. Contents of a is equal to %f a normal usual way of taking out the value of a variable. Now contents of c, what c will contain, then what b will contain, and how to access a variable whose address is assigned to a pointer and that pointer is assigned to another pointer. So if we look at contents of c, it is %uc. What we expect here is the address of a which has been assigned to c. Contents of b is equal to %ub. Here b will be holding the address of c, and contents of a is equal to %f. Now how we are taking out the contents of a? Through pointer notation or value at address notation, and here we are using star into the bracket star b. This gives us the value of a. Whereas contents of a, value of a will also be made available to us by this statement. which uses star C or the value at address held by C, that will give us again a value of A. So these are the output screen snap. I have snapped it, screenshot of the output screen. Address of A, B and C in the first three output statements. Value of A obtained in the usual way of %f and writing the name of the variable. Contents of C. What C holds? C holds the address of A, which is 65522. Contents of B. What B holds? It holds the address of C, the variable pointer variable C, which happens to be 65518. Now contents of C is, sorry, this must be content of A, which is taken out with pointer notation or value at address notation through pointer to a pointer. B is a pointer to a pointer C. Now we can see here A is stored in 65522 location, starting address 65522. B is stored in locations 2021, which contains the address assigned to it, which happened to be the address of C. C stored in two locations 6551819, and to which we have assigned the address of A. C holds the address of A. Star C yields value stored at address held by it, which is 10. Star C yields value stored at address held by it. Here C is holding the address 65522. So star C will give us the value stored at 65522, which happen to be the value assigned to A, and which is 10. B holds the address of C, and star B yields value held by C, which is 65522, that is the address of A, and star B will give us the value 10 stored in A, but how we are accessing it? Through a pointer to a pointer. B holds the value of C, C holds the value or address of A. A small program, pointer to a pointer, 5 variables declared, A is equal to 10, star C, star D, and result. What this star D tells us? That it is a variable, pointer variable, to which another pointer variable's address will be assigned. C is equal to AND A, ampersand A causes assignment of address of A to C. D is equal to ampersand C. So the pointer C's address is being assigned to D, another pointer variable, which happened to be a pointer to a pointer. And now what we are doing here is result is equal to star C. This star, another star, second star, after star C gives us value stored at address stored in C. So it gives in us 10. This star, second star in the expression, is a multiplication operator I am using, and star of star D, what it will give me? Star of star D will also is also pointing to A, so it will again give me 10, value of A. The screenshot of the output screen, result is equal to A. Naturally, A contains result is equal to 100 because star C gives us 10 multiplied by star of D, which again gives us 10. So the result will be 100. Address of A 65524, address of C 65522. Contents of C is whatever is the assigned value to it. In this case, it is address of A. Naturally, it will be 65524. Address of D, D is stored in 65520. Contents of D, what we have assigned to D, ampersand C, which is the address of pointer variable C. So C contains address of A, which is 65524. Star C gives value stored at 65524, which is 10. Star D into the bracket, this expression into the bracket star D gives us value stored in D, which happens to be the address of C. D is equal to ampersand C, that is the assignment we have made in the program. Star of 65522 contains address of A, which is 65524. So star of star D gives value stored in 65524, which is 10. Now let us go for a simple but a fun program. Please note, the logic used in this program should never be attempted in actual serious programming. Why? That we'll come to know when we go through the program. There are two float variables, x and y, assigned with values, and a third PTR, star PTR is a pointer variable of type float. We are taking out the addresses of x and y by using this printf statement. Then the PTR, the pointer, is assigned the address of x. PTR is equal to ampersand x. And now by using indirection operator, the star operator, we are accessing the value stored at the address assigned to PTR, or simply the value stored in x. Then the PTR is being incremented by 1. So now it holds the address which is 4 bytes away from the address of x. Now we are trying here to find out the contents of PTR through the printf statement, and then we are finding out the value stored in a location pointed to by PTR. Run of the program. When I ran it on my laptop, this is the screenshot of the output screen. what we can find here is address of x and y is given by this printf statement. The contents of x, which is 2.22, these are obtained by using the statement printf %f star ptr, and the same ptr to which we have assigned the address of x by this statement ptr is equal to and ampersand x. By the same ptr we have been successful in getting the value stored in y. We have seen here nowhere we have assigned the address of y to ptr. We have assigned the address to ptr only of x, but by incrementing ptr we are able to get the address of y. This has happened just by chance, because in many small programs which we have attempted up till now, we have seen that there is a fair chance that the compiler allots the memory locations in contiguous memory locations to 2 or 3 variables of the program when the program uses very small number of variables. In this program, just for fun, please note this is for fun, we are not going to use this kind of logic anywhere in any of our programs. Just for fun, we are trying to access the values of both the variables using pointer of only one variable, pointer to only one variable. This contiguous allotment of memory locations in this program for x and y is purely a chance. Compiler does not have any method, or it will never allot contiguous memory locations to all the variables in our program, but here in this program it has happened by chance. But compiler does allot contiguous locations to the values stored in an array. So array is a type of variable where we can have number of values stored in one array, and each value is stored in the memory location in contiguous way. So this is all about arithmetics of the pointer and pointer to a pointer. Please subscribe and share this video. Thank you very much.